Weather at sea can change in an instant, but how do mariners stay ahead of storms and navigate safely? Weather surface analysis, also called a synoptic chart, provides a real-time snapshot of atmospheric conditions. It maps pressure systems, fronts, and winds, helping mariners make informed decisions. For mariners, interpreting these charts is critical for route planning, avoiding severe weather, and ensuring safe voyages. In this video, we'll break down how to read a weather surface analysis, understand key symbols, and apply this knowledge at sea. Stay on course. Let's dive into weather surface analysis.
This is a high-pressure system. It is an area of higher pressure with a clockwise circulation in the northern hemisphere and counterclockwise in the southern hemisphere. This system is also known as an anticyclone and typically brings fair weather and clear skies. Next, we have a low-pressure system. It features a counterclockwise circulation in the northern hemisphere and a clockwise circulation in the southern hemisphere. Also called a cyclone, this system is often associated with storms, strong winds, and unsettled weather. Here, we see isobars. These are lines that connect points of equal atmospheric pressure. Isobars help us identify high and low pressure systems and determine wind direction and strength. The closer the isobars, the stronger the winds. This symbol represents a cold front, the leading edge of a colder air mass. It separates two air masses with sharp temperature and moisture differences. In the northern hemisphere, winds ahead of the front typically blow from the southwest and shift to the northwest after passage. Now, let's look at a warm front. This marks the boundary where a warmer air mass advances. Like cold fronts, warm fronts have strong temperature and moisture gradients. In the northern hemisphere, winds ahead of a warm front come from the southeast, shifting to the southwest after it passes. A stationary front is a boundary that remains in place without significant movement. It can bring prolonged periods of cloudy skies and precipitation in the affected areas. Here, we have an occluded front, which forms when a cold front overtakes a warm or stationary front. If a cold front catches up to a warm front, it's called a cold occlusion. If a warm front overtakes a cold front, it's a warm occlusion. This process eventually leads to the front dissipating. This blue dotted line represents the ice edge, as defined by the U.S. National Ice Center. It marks the extent of sea ice coverage of 10% or greater, critical information for polar navigation and maritime safety. Next, we have a trough, or trough. This is an elongated area of relatively low pressure, often associated with unstable weather and cyclonic wind shifts. Finally, we see weather stations. These stations provide real-time atmospheric data, represented by a small circle on a synoptic chart. The surrounding symbols and numbers indicate temperature, pressure, wind direction, and other vital weather conditions. Understanding these symbols is essential for interpreting weather surface analysis. Mariners rely on these charts to predict weather patterns, avoid hazards, and navigate safely at sea.